All right, so this slide kind of sums up what we were just talking about between the two pieces of positive and negative areas under the curve. So if f of x is non-negative, in other words, all of its graph is above the x-axis, then to find the area under the curve, we just evaluate the integral. However, if f of x is negative, in other words, there's part of our graph that's below the x-axis, then to find the area under the curve, we make a small change to that integral, which we just talked about, and we just put a little negative sign in front of it, okay? Sometimes the area between f of x is both non-negative and negative over an interval that we're interested in. So in that case, we look at both of the integrals combined. What if I had a graph that looked like this? Let's just take what we just have been working on with that semicircle, and let's say we've got some graph that has a semicircle above the x-axis here and a semicircle below the x-axis here. Now this is not a sine curve, okay? We would use the same thing with a sine curve, but we're not going to talk about a sine curve today. We're going to keep things a little bit simple. These are circles. Okay, so here's x-axis. Right here, this is all positive. This is positive area. Right here, this is all negative area. Okay? But what we do is if we take the top minus the bottom, in other words, we're going to take our positive area minus the negative area, then we would see that we're going to have the total area. So let's go ahead and let's say that we've got a radius of 2 on this bad boy right here. We've got a radius of 2, and let's call this guy a radius of 2 as well. We just worked a problem out like this, and we discovered that this positive area is 2 pi. And we discovered that this negative area was going to be negative 2 pi. So according to this bottom function right here, this bottom rule, if I want to find all the area under the curve, I would take 2 pi minus negative 2 pi to get the area, which in this case would be 4 pi. You could also find the decimal version of that. And it looks really weird, but this is how you're going to find the area above and below. So if we've got some kind of goofy shapes going on, what we would need to do is find this point of intersection on the x-axis, and we would find the area of the first minus that negative area of the second. And that's it. That's all you have to do for this kind of thing. So don't let this be super challenging or difficult.